Of the more than 1,000 active or potentially active volcanoes worldwide, not all of them contain a highly symmetrical and towering peak. Yesterday's video discussed these types of volcanoes, while today's video will discuss the remaining 7 volcano types. Let's get started. When viscous lava erupts, it does not always form lava domes. In very rare cases, viscous lava, typically of an andesite to dacite composition, can be associated with eruptions that have a low gas and volatile content, making them less explosive than a typical lava dome forming eruption. As a result, viscous lavas will repeatedly travel downslope, albeit not very far, and pile on top of one another to form a type of volcano known as a lava cone. The most catastrophic eruptions in the world often eject many cubic kilometers worth of lava either effusively or explosively. When this occurs, it can cause the underlying magma chamber at depth to drain, causing structural instability in the crust overlying it. This can then cause the crust to collapse downwards to fill the pockets of air in the magma chamber, which forms a circular depression in the ground known as a caldera. These calderas are typically at least 2 kilometers wide, but in some circumstances can form to be more than 100 kilometers across if thousands of cubic kilometers of magma was removed. If a volcanic eruption occurs underwater, the pressure from said overlying water will impact how it occurs, generally making eruptions at deep submarine volcanoes less explosive. This is not the case, however, if a submarine eruption occurs at shallow depths, as it then becomes more explosive. However, the term submarine volcano simply applies to any volcano which has its highest point underwater. When magma erupts into a thick ice sheet, it forms a subglacial volcano. During such an event, erupting magma initially forms a layer of material which looks much like a dome out of pillow lava. As eruptive activity continues, the heat melts significant volumes of overlying ice, creating a thick glacial lake in the volcano. After the glacial lake develops, eruptive activity shifts to a more explosive phase, depositing a rock type known as hyaloclastite. If this eruption occurred from a singular vent rather than a fissure and stopped at this point or a prior phase underneath a glacier, the resulting landform would be known as a subglacial mound. However, things change if the eruption continues. Over time, the erupting vent, which now has an unusually steep profile, reaches the surface of the lake, causing eruptive activity to change once again. Instead of being highly explosive, more effusive to moderately explosive eruptive activity occurs, sending lava flows to fill the area previously occupied by the lake. The movement of the lava is partially constrained by the presence of the glacier, forming a flat-topped edifice. If that entire sequence occurred from a singular primary vent, then the resulting landform will be called a toya. However, if the subglacial eruption occurred from a fissure vent, regardless if it had a lava cap or hyaloclastite, the resulting landform will be called a tindar. Some volcanoes do not have a large central edifice, but merely mark large craters in the ground. Take, for example, this giant explosion crater of the Soda Lakes volcano in Nevada. This complex consists of 2 explosion craters, one of which is 2 kilometers wide. These craters are referred to as Mars and form when rising heat from a body of magma encounters groundwater at depth. The groundwater then flashes to steam, builds in pressure, and explodes upwards, forming a Maar crater. A similar volcanic feature known as a Tuff ring forms when the same process takes place, but instead with a body of water on the surface. When this occurs, an explosion crater is generated but is not as deep and has a highly rounded ring of debris at the crater's edge. For example, this is the Herverfjall Tuff ring in Iceland, which represents a prior event of the Caldera Volcano that formed 2,500 years ago. However, if repeated explosions occur over a longer duration, then a tuff ring might build in volume to become a tuff cone. Technically speaking, if a volcano contains a wide series of vent types such as multiple stratovolcanoes, lava domes, and related vents which are closely spaced, you form what is known as a complex volcano. One example is the Tongariro Volcano in New Zealand. If a volcano contains multiple vent types but with no or very few exceptions, each vent only erupts once, then you have a volcanic field. It is best to describe a volcano in my opinion based on its most prominent or largest feature, as most volcanoes contain multiple volcanic landforms. For example, while the Darwin volcano in the Galapagos Islands contains a shield volcano, caldera, cinder cones, and tuff rings, since the largest portion of the volcano is a shield volcano, I would classify Darwin as a shield volcano. As a final note, I would like to thank my new YouTube channel member Hussein Tamer for supporting this channel.